So today we're going to solve systems of equations using matrices. Now we've already done this, but today we're going to do it the final way, and most students actually like this the best. But before I can actually get into solving systems of equations with matrices, I need to know, how else have we solved systems of equations? So raise your hand to give me one way out of the four that you now know. Ian. Graphic. That's one. Elimination. That's two. Substitution. That's three. You've got one more way that you learned this chapter. Okay, you learned this chapter. What? Kramer's rule. So right now you have four ways. Now, we learned that we liked elimination better than Kramer's rule if there were only two letters. But if there were three letters, we probably like Kramer's rule better. Right?
Right.
For most of us. Most of us probably agree, and I don't know if Ian agrees with me or not, but we don't like graphics. Okay, how many of you agree that you'd rather do elimination than graphics? Okay, and that's perfectly fine. Because if you have to retake the keystones for any reason, or maybe you just transferred in and you have to take them for the first time, they don't say you must solve this by elimination or substitution. They can say to solve it. So you have lots of different tools in your toolbox. So we're going to solve this lovely problem right here. And you will, for the most part, like this the best. So we're going to solve this lovely system of equations without using substitution, elimination, graphing, or Kramer's rule. But we'll use matrices. We actually need to make three different matrices. Okay? The first matrix is going to be a 2 by 2. It's got to be a 2 by 2 because I have two letters and two equations. And this is called my coefficient matrix. Have we heard coefficient matrix before? Yeah, in Kramer's rule. Okay, see if you can fill that in knowing what you knew from Kramer's rule. This is the coefficient matrix. See if you can fill that in knowing what you just knew from Kramer's rule. This would be on the bottom of a fraction in Kramer's rule. Raise your hand if you can fill that in for me. Lauren. That's correct. Good. Good. So that's an easy one, right? We already knew that. The next one are your variables. Really difficult one here. What are my two letters?
X and Y.
Okay, X goes on top, Y goes on bottom. Okay, if it was three letters, you'd write X, Y, and Z. Okay, but you put them in order. What if it had been A and B? Which one would go on top?
A.
Good. Equals your answer. My answers here are negative 19. And 1. Now, hey, that first problem we did this morning, where you had to use A inverse B, doesn't that kind of look like it? Except instead we used giant X, right?
Right.
So what do you think I'm going to have you do here? I'm not trying to change anything up on you. Well, I'm not adding anything here. How? How? You're right. How? What do I have to use in order to get that X by itself? Anna? Well, I can't subtract because there's no plus sign. Oh, I can't, remember, no dividing. Never. Yes, that's it. Inverse. So I'm going to put this into A. I'm going to put this in B in my calculator. Which one, Anna, do I need to take the inverse of? Yes. So I'm going to do A, inverse, B. So, we found our two answers, right? Abby, what'd you get? And it looks like this, right?
Right.
That means X is negative 3, and Y is 5. So my answer is actually negative 3, comma 5. That's all the work I had to do to solve that system of equations. Now I always made you check, so let's just check in my our head here. 3 times negative 3 is plus 2 times 5, which is 10, is negative 9 plus 10, 1.
Yes.
That's quick and easy, wasn't it?
It was.
Okay. All right. Well, we always know that if it's a system of equations, you're going to do a word problem. Take a minute. We're going to do a word problem. What's the first thing we always do, Ty? Okay. What's after that? Variables. Then equation. Then solve. Okay. So if you take a look up here, I have my 2 variables. I decided to use x and y. And the only reason I decided to use x and y is the soft tacos to me began with the letter S. And burritos, the letter B. B doesn't really matter so much because I don't see any 6's in there. But S to me looks a lot like a 5. So I noticed you actually used the letter T, didn't you? That works. That's fine. You can use different letters. So I used X, I used Y. Now, in order to solve this, I don't want you to do this by elimination or substitution or graphing. I want you to use the matrices equations. So first thing, rewrite it using the matrices equations that we just talked about. So there are my matrices equations. Now plug them into your calculator, find the 2 answers. Alright, so here's my answer I get when I put this in the calculator. 1.25 and 2.5, right? Now, when you're writing your sentence, you actually need to say soft tacos cost $8.25. You don't have to write that all out in words. You can write $1.25, that's fine. And burritos cost $2.50. That's $$2.50. I know that sounds silly, but you need that 0 right there because you've never walked into a store and they're like 2.5. They don't say that. Okay, they always have that 0 on the end. So pretty simple to do systems of equations this way, right? In fact, it's so simple. I've got one last problem for you guys to do together. 3 variables. You don't have to write the equations down this time. How about this? Just write down the matrices equations that you'll be using in your notebook, and then use your calculator to solve for x, y, and z. For anybody that did the bonus, remember these would take you a full page to do. We're now going to narrow it down to exactly 4 lines. So by now, you've made your lovely matrices, okay? Since there's 3 variables and 3 equations, the first thing you should be thinking is it's a 3 by 3. You have to have those ones in for the z's. What if one of the z's were missing? What would you put in? You would put in a 0. You have to put in a 0 if a letter's missing. You have to. And so the answer you should write down, 2, negative 1, negative 2. You should not write your answer as a matrix. It's an ordered pair. So you have to transfer it back to the ordered pair.